If you involved in training a model, we need to evaluate the model whether it is predicting the target as expected. Let's take the linear regression equation again, where x is the independent variable and y is the dependent variable. Model prediction is termed as y hat. So y minus y hat equals difference in values, which is actually called as error. Y hat termed to be a predicted values from the model. So subtracting your y hat with y is the difference in values, which is actually an error. Calculating this loss is called loss function. Now, in order to tune the model to achieve it, to get close towards, let's adjust the weights and bias. So, choosing a weight plays a major role here. Let's take, which is your model function. On the other end, let's have weight as your parameters to tune your model. When weight equal to 1, it makes the line straight like this, which makes the equation with no error. And the calculation goes your independent variables, your y hat minus your target element. So let me give you the formula for cost function, which is 1 by 2m summation of, which starts from the first row, which is I equal to 1, and n till m, which is your last row, which have m rows, and your target and the predicted values, the whole square. If I substitute weight equal to 1, I get 0 as my cost function. I'm taking another weight, setting it to 0, and bias is 1.5. Likewise, I get the plot which showing here. So W equal to 1 is the best choice to have a low error in order to obtain the best fitted line. So that's how the model gets trained in regression models. This one is a linear regression, but we do have other nonlinear models of regressions which will have similar evaluation method or weight calculation method, but learning of an algorithm will be different.